Here we're going to talk about ion formation. And remember from the first slide we went over previously that an ion is an atom with a charge. And there are two types of ions. Okay, the first is a cation. That's why there's this picture of a cat here. Okay, so cation, and a cation is a positively charged ion. An anion is a negatively charged ion. Okay, but an ion is an atom with a charge. So let's explore those right now. So here we have just fluorine taken off the periodic table. And if you look at fluorine, it has it has 7 valence electrons. And how do I know it has 7? Well, it is in group 7, okay, or group 17. And again, we're just looking at that last digit there in 17. The 7 will tell us how many valence electrons each of these atoms has. And fluorine has 7. So let's go back to here. All right. So we have our electron dot structure of fluorine. And fluorine wants to be like the next noble gas. And which is the next noble gas? So we go to the right. The next noble gas is, well, it's right next to it. It's neon. Okay, so let's do the electron dot structure just really quick for neon. Let me get my pen out, and I'm just going to write it right here. So here's neon. Neon is Ne. And we have 1, 2, 3, 4, 5, 6, 7, 8 valence electrons for neon. So it has a full octet. Okay. So fluorine on the periodic table has a charge of 0. Okay. How do you know this? Well, fluorine has the atomic number of, where you can't really see that. It's covered by this. There we go. Fluorine has the atomic number of 9. Okay, it's right here. You can see that there. Fluorine has the atomic number of 9, which means it has 9 protons. And protons are positively charged. And if it's neutral, it has the same amount of electrons. Okay, so electrons are negatively charged. And you subtract those two. So you get 0. So how did you get 9? Well, there's also 2 electrons in the first orbital. The valence orbital has 7, so 2 plus 7 equals 9. So we have a neutral fluorine atom. Okay, but fluorine's not happy. Okay, fluorine is jealous of neon. Fluorine wants to have 1 more electron to have a full octet. So fluorine will gain an electron right here. It is gaining this electron from somewhere. Okay, it's gaining an electron. Electrons are negatively charged, and now fluorine has a full octet. Oops, fluorine has a full Fluorine has a full octet. Has 8 electrons in its valence shell. Okay, still has the 9 protons. Okay, protons do not change. So 9 protons. It gained an electron. Electrons don't have much mass, but they have a negative charge. So instead of 9 protons, we have 10. And we subtract these two, 9 minus 10, and we get a negative 1. So now fluorine has a negative 1 charge. Okay? So fluorine gained an electron from somewhere. Electrons are negatively charged, thus changing the charge from a 0 to a negative 1. All right? So that's fluorine. Let's talk about sodium. Okay? Sodium on the periodic table is an alkali metal. It's all the way over here. Okay? So again, the goal for atoms are to become like the next noble gas. Now, because this is so far away from argon, see, argon is, if you drew like an imaginary line from across period 3, right, the next noble gas would be argon. But actually, the closest one to sodium is neon again. Okay, so sodium's here, neon is just kind of 1 back. So again, I'll write out the Lewis structure, electron dot structure for neon in E. And we have one, to pretend that's an electron. Let me get a better circle. I'm doing the best I can with my mouse right now. I don't have a stylus. Okay, 3, or that's 7 and 8. Okay, so now we have a full octet. And sodium wants to look like this. Okay? What sodium can do is, because sodium is in the third period, it has 2 electrons. Let me change this. It has 2 electrons in the first orbital, 8 electrons in the second orbital, and 1 electron in the last orbital. And that's what we see here. Here's our Lewis structure. Here's our electron dot structure with sodium with 1 valence electron. Okay? And the charge with sodium directly from the periodic table is 0. Okay? It has 11 protons and it also has 11 electrons. So we add these up. 2 plus 8 is 10, plus 1 is 11. So we subtract those two numbers and we get 0, no charge. But sodium's not happy, okay? Sodium is not happy. Remember what I said about the octet rule? The octet rule states that atoms tend to gain or lose electrons. So this is a case of an atom losing an electron, okay? So sodium is going to give up an electron right here. It's going to give away a negative. If you give away a negative, you become more positive, all right? So instead of having 11 electrons, sodium has 10. It gave away an electron. So now the difference between the protons and electron is a +1. So now sodium goes to +1, or the plus. If there's a 1, or if it's a -1 or a +1, we really don't write the notation, the superscript. That's called the superscript when the number or the symbols all the way at the top. We don't write it if it's a plus or -1. We just write the plus or the minus. So for sodium gives up an electron. It's a +1. Okay. What about magnesium? Again, magnesium wants to look like the next noble gas. So let's look at our periodic table. Okay. And here's magnesium. The next noble gas, you would think it's argon, but it's not. Okay. It's actually neon. So magnesium wants to look like neon. So let's go to our problem here. And magnesium orbitals look like this: 2 in the first orbital, 8 in the second orbital, and 2 in the last orbital. Now, or 2 in the valence or last orbital. Now, magnesium wants to give up 2 electrons. Okay, what's its charge? Well, its charge initially, before it gives up the electrons, is 0. It has 12 protons. It has 2 in the first orbital, 8 in the second orbital, so that's 10 total. And then the valence orbital brings the total to 12. So 12 minus 12, 0. So if magnesium gave up those 2 electrons, so it got rid of that, it got rid of that 2 to look like this, okay? Now there would only be 10 electrons, so 12 minus 10 is a +2. So now it's a +2, you put the number. You only don't put the number if it's a 1, okay? All right, so that's magnesium. Magnesium will again have a full octet. See that 8 there, full octet. That 8 there, full octet. So sodium and magnesium both will have a full octet, and they'll look just like neon, the next noble gas. The trend you'll notice, let me go to our periodic table. So you might be asking, why are these, some of these are gaining electrons like we looked at earlier, and some of them are losing electrons. Well, the ones that are losing electrons are metals, and the ones that are gaining electrons are nonmetals, and that's the trend that we're going to see.